Hi, my name is Amritam Putatunda. I'm a senior product manager for Keysight's application and security. Today, I'm going to talk about zero trust. And I'm going to start with this statement. Zero trust is not going to work. It's not going to solve your security problems unless you get the entire ecosystem to be part of the zero trust. If you see, right, consistently on the breaches and the attacks that has happened all the time, over the time, nobody goes for the strongest links, right? It's not an ego challenge where hackers are trying to go and inflict on the strongest firewall and strongest technologies. They're always going through the weakest links, right? And then the companies come out and blame interns, some support staff, contractors, smart fridge, whatever, right? We find people to blame, scapegoats. But the point is, when we are deploying a technology that's all about authentication and authorization, it needs to take everybody together. And that's where the ecosystem play becomes very important. You need to have everybody together. And one of the issues with technology evolutions is that it's different than biological evolutions. In biological evolutions, we can clearly see if a new, better variant comes, the previous variants are just replaced by it. Like, in pathology, nobody needs to know how Homo erectus were working to treat Homo sapiens, right? But in technology, it just stacks up. It's incredibly difficult to replace older technology, especially if these technologies were very successful during their time, right? So it's important, and in this next few moments, or 15, 20 minutes, I will try to take you through 20 years of evolution. So please be patient with me if I'm fast and going too hard. But I would try to say, what are the things that were existing and still exist, and how we can tie everything together into zero trust. So our first thing would be how networks were 20 years back, right? Things were much simpler, 9 to 5 jobs. We were working from offices. When we logged out, we could not get in anymore, right? So my first demo would be on that. But before I go into this, I need to very quickly show you how this tool actually works, right? So CyPerf has this controller. So this is like a single mothership, a controller that you deploy once, okay? And these agents are like small endpoints that you can deploy anywhere, like the previous speakers have told. You can deploy it in 2 laptops, like I can just deploy in 2 of these laptops and wreak havoc in this hotel's Wi-Fi by sending all the applications and attacks through it. Not going to do that today because we want Tech Field Days to continue and Andrew and Stephen not to get into trouble with the hotel Wi-Fi. But for this particular demo, what I've done is I have deployed these agents in our office premise in a little more controlled environment than this, in a powerful virtual machine, multi-core CPUs, and we are going to send traffic through between them for the initial demo. This would give a good setup for us to go into much more complicated stuff. Sir.
So your heavy computer that you've got these on, is it acting like a synthetic test with multiple virtual NICs?
It can be. So it's basically, you can think of it like, for this particular setup, I have a virtual machine. I deployed this software, and this software would now generate tons of transactions, connections, applications, attacks between 2 virtual machines, end to end. Okay. So if there are NICs, you can say, okay, point it out to the SRIOV supporting NIC or a quick assist supporting NIC. So you can route the traffic to certain NICs as well.
But does it synthesize multiple clients, multiple MAC addresses?
Yes.
Multiple logins, all of those?
Absolutely.
Off of one. Is there a limit of how many agents can run at the same time?
Yeah, so we tested, so each agent, individually we say they can up to generate 10,000 unique IP addresses, unique MACs. And in a single test, we generally recommend to not use more than 30 agents, but individually, each agent is powerful enough to go for 100 gigs of encrypted traffic.
Why don't you just show us?
Sorry?
Why don't you just show us?
Yes, absolutely. So as I said, this is a progression of 20 years. So the first one we will try is an evaluation of traffic on-prem. So this is where you can see these 2 virtual machines, right? So this is one side simulating the client, the other side simulating the servers. This is where you see the IP addresses, and you can see I have used multiple IP addresses. So the count starts at 10.0.0.10,
Could you zoom in a bit?
So the count starts at 10.0.0.10, but it increases up to 30. But you can obviously use up to 10,000 IP addresses per agent. If you have more agents, you can do more. And these are the applications that would be, little more on-prem friendly, like we have SMTP, MongoDB, HTTP app. 20 years back, Facebook didn't exist, but we had Orkut, some variants of, let's say, social media, and some voice calling. And this is the applications in the simplest of its form that most of the time the users during this time would not be aware that there are network security controls in between, right? It would be either transparent proxied into it or natted into it. And the traffic would go through to our data center, which in this case is also located within the same location. So very simple config, setting up client and server with different applications. And this particular one, because we are talking about, let's say, a company that is 18 years ago, we have like 1,000 users, and let's see what happens. So in the interest of this demo and the time, what I have done is I have pre-run most of these tests, but I'm going to run some of the tests as well. So we can see the statistics and understand what kind of throughput applications and things like that we can get. So this test has been run for last 10 minutes, and you can see we can around get 7.5 gigs. These key performance indicators won't change as our topologies become complex. What will change is what we see, what we understand more, like when we add VPN, when we add other type of things, we'll see specifics, but the key KPIs, how much throughput you get, what's your cumulative latency, how much transactions you see, what's your connection rate, what's your application mix, this kind of things would still remain the same.
So question.
Yes, please.
This traffic that you have, did you guys get this from putting an agent and watching the traffic in the network, or is this what you have a historical database of just kind of like a baseline of what these particular traffics would look like?
We have been in this business of traffic generation from last 15, 20 years. So we are building up this database through our application and threat intelligence team that's analyzing the traffic in the network, that's understanding what kind of signatures that it would look like in real life, and then replicating it within this simulation environment. However, the important point to note is that it needs to look exactly how the real Facebook, real Office 365 traffic looks in real life. Otherwise, deep packet inspection devices will call our bluff and just block us on the route, right? So we'll not be able to test realistically. So if you see any of this traffic, or in fact, if I go through some of the entire transactions of this traffic, let me show, let's say one of them. Since the question came up, I'll go to my favorite screen. So you can see how a Facebook transaction would also cater to multiple servers and different servers, because that's how the single login and adding a chat request in Facebook would work. So it's trying to be as close as the real thing in network. Now there are other statistics. So we start with the KPI, but the whole point here, like Kevin mentioned, is to go into as much depth as possible, because as a test tool, all we are trying to do is find out issues, find out problems, find out your datasheet numbers and how different your actual numbers are from datasheet numbers, right? That's our job as a test tool. The other thing, because we are running in hardware, so this is one of the questions that came in, we are also trying to ensure that we as a test tool do not become a blocking point. So when you are measuring performance, not security, when you are measuring performance, it's important for you to understand that whether the software agent that is running is able to extract every ounce of juice from the systems it's running, if you're doing high performance test. So we publish per core stats. We also publish memory stats of the host so that you know where exactly the choking point can be when you are really going for performance numbers. Okay, so that was my first test. So after on-prem came this new trend of working from home, right? After that, you could not really, be in a bar and tell your boss that you cannot log in because you are not in office anymore, right? So VPNs came in and remote work started, right? Obviously, with pandemic, what happened was that this got into a very, very different scale. Now, when we are talking about zero trust, I know some of you are thinking that why I'm not talking about SDPs, because zero trust is saying that SDP is going to replace VPN. But the amount of requests we got as a test company for testing VPN during this pandemic shows that VPN, just like any of these very successful technologies, it's not going to go away suddenly. They will coexist for a very, very long time. So it was important for me to show you that CyPerf as a tool is trying to emulate all these aspects of technology evolution. So with VPN, you can use the same CyPerf, just like you have been probably with on-prem doing IP addresses, v4, v6, VLANs. With this feature, you're able to simulate VPN tunnels. And you can select your vendor, your preferred VPN vendor. You specify the configurations that are specific to those vendors, the authentication settings and things like that. And CyPerf will scale thousands and possibly millions of tunnels, provided you have enough agents, enough firepower, you should be able to do it. And our purpose of doing this is to ensure that we are generating applications and attacks through those VPN tunnels, exactly how it will happen in real life, right? Now, I gave a big dialogue about how every technology in part of technical evolution gets stacked up on top of each other, right? So to follow through, I wanted to run this test together with on-prem, right? That's how the true stacking will work. So we are already, maybe I will try to zoom out a bit and let me know if it's still clear. So we are already familiar with our on-prem systems, now have stacked the VPN clients. So this is network 10 years before today, right? So we have VPNs, customers coming in from outside, and we have applications that are coming in. So you can see in the application profile as well, if I expand, I have added some of the existing on-prem apps, but I have also integrated some VPN apps, which remote users are probably coming in and connecting to. And both of them now coexist together in a very happy symbiotic life. So if we go to statistics now, you see some of those KPIs you have already seen in on-prem, where we saw our throughput. Obviously now throughput has become a little more. We have few thousand users added because of the remote work. And we can see the application mixes, the percentages are getting respected, and we can see VPN tunnels getting created. So this is the new stat that got introduced here, right? When you enable VPN. Not just that, as I mentioned, as a test tool, our whole purpose in life is to find out problems and issues so that the actual users don't find it. And you can see, you can go into really depth of these stats, like how many tunnels were set up, what was the tunnel setup rate, was there any failures, any issues, any timeouts, right? Which can happen in this kind of environment because all this needs a lot more encapsulation and encryption. So you can see some of those things. You can also go into individual applications. Now, this is important. You have to see these individual applications when they're running both VPN and on-prem and see if there are some transaction failures. Is your network acting slower when VPN is coming there? So you need to see all those things, and this individual application stats would allow you to see that.
Sorry.
Can I jump in with a question here?
Please, please.
We're talking about end-to-end testing and some of the applications you're talking about. Do you have a solution for two-factor authentication? Is there, like, how do you integrate two-factor authentication into your test suite, or do those applications not get tested?
You're right. Two-factor authentication, the biggest challenge of it is to get this second factor on, which is like SMS, authenticator apps, and things like that. So what we were trying to understand from our customers, those are big equipment manufacturers and service providers, is that what are the things and in what order should we be adding that? So the Zero Trust demo, which I will be coming to, you would see it doesn't really involve two-factor authentication, because right now the big problem that these vendors have is to measure the scale. And it's true for any new technology, right? When you place deep packet inspection for the first time, the biggest problem was latencies. And that's why some of those products were put out of band, right? So with this, when you're enabling Zero Trust and authenticating and authorizing every request, every application, every location, the big problem has been with scale. But when and that's why we are trying to go after scale, sending hundreds or thousands of users and passwords and certificates and all those things. But the second phase is also we are trying to work with companies like Trulia, which has ways to simulate and understand two-factor authentication. And we are trying to integrate them together so that we can also do scale of two-factor authentication. That would be a huge challenge, which geniuses like engineers and team like them will do it, and I will take the credit for it. But yes, we are definitely looking for that.
How is the weight calculated for each application?
So you see these applications and you see these weights, right? These are all editable. The whole point here is to give you the applications and give you the flexibility to find out what kind of application mixes, how it reacts in the actual network. What can happen is, let's say, your company has 40% Salesforce. I'm just making a, and 30% YouTube. And now you put weights as 40% Salesforce and 30% YouTube, and you run it, you see your network might be only be able to do 10% of Salesforce and 70% of YouTube, right? So you are understanding from that application mix that what you have set and what kind of throughput you get for that particular mix, right? So that's the important point where we need to specify weights that you create your own personas and find out the KPIs based on those personas.
Okay, but is it related to like maybe the speeds or
No,
like,
weights are, okay, yeah. So weights are based on the objective. So let's say here I have an objective of 1,000 users, right? So the way and the distribution, you can see 5, 5, 5. So 5% of the 1,000 users are going to do Skype, right? So like that, that's how the weights are distributed. And it's the same when we change objective like throughput, connections per second, that gets the same kind of distributions. Okay, so we are already into it. So the third phase of this technology evolution was the cloud, right? When we were walking around RSA in 2018, 2019, all we were hearing is this cloud is coming for you, right? Guess what? It came, it conquered, it got deployed, and it conquered, right? We talk a lot about remote or hybrid workforce now, where people will work from remote and home. What cloud also has done is enabled hybrid network topologies, right? Now, deploying security application devices in network has become much more easier with cloud. And that's why we have to talk about cloud, but we cannot talk about cloud without talking about key features of the cloud. One of the key features of the cloud was auto-scaling, elasticity, containerization, flexibility, right? If you had data centers that were supposed to scale up from 50% to 80%, let's say 10 years back, it would be a 3-month project. With auto scale and load balancing and all this provided, this can happen in like 5 minutes now, right? And we wanted to see as a test tool, be able to simulate that. And how do we do this is that with cloud, even though the client side, like when you are allocating agents, so this is the agent allocation screen of CyPerf, you can see all the agents that are already connected to the UI, the mothership that I talked about. So generally you allocate agents with IP addresses because their IP addresses would be known beforehand. But with cloud, what we do generally is that at the server side, we cannot allocate IP addresses of an elastic network, elastic pods, because those IP addresses would not be known beforehand. And that's where we allocate cloud by tags, right? And you can see, like in this case, I have allocated a tag named server farm behind ALB. And this tag, whenever there is an auto scaling happening, new entities will come and join in. So that's how we are taking care of elastic problems with cloud. And what we have, and this also allows us to be distributed around the place and be testing a variety of security controls here. It can be secure SD-WAN, SASE. It can be content delivery networks that are looking for the best possible points of presences to their applications. It can be, service providers and cloud themselves deploying their agents in a right position. So this is where, since you're asking about the problems, so this is where the most number of problems got discovered. What we found is when devices were put in their on-prem infrastructure, they were working fine, right? In the lab-like environment, they were working fine. But when they were deployed in cloud, there were so many components in between. It can be internet service providers, the cloud service providers, each of them have their own policies, own nuances, and a lot of issues were getting introduced by them rather than the vendors. And it was very difficult for a customer to weave through and find out which all issues were because of the product itself or because of the shared security model, the latencies, the individual policies of internet gateways and NAT gateways of cloud itself. And the second point was when cloud was claiming elasticity, elasticity is still very unpredictable. It depends on the time zone you are in, at what time you are in, and at what kind of traffic that particular cloud is getting at that time. Finding out predictable results now needed you to run tests in a regular cadence and find out, okay, my 9 a.m. test was showing this results, whereas my 10 p.m. tests, we expect that results. So my QoE or quality of experience for users varied depending on when the tests were run. And that was the fun of cloud. And we had a lot of interesting data points and factoids. Some of them will be released when we tested cloud. And all the security devices that I have been testing all this time, when I tested in cloud, it gave us a very, very different results. as well.
You talked about running tests at specific times, right?
Yeah.
And I understand that that's what you need to do because different demands.
Yeah.
But what kind of mechanisms do we have to make sure that at 9 a.m. I don't take down the entire network because everyone's logging in at the exact same time, and then I'm adding 4,000 users simulated on top of that?
What we generally do is our objectives can be users, but we also can provide constraints. So this is where, when we are doing it a proper CI/CD, where I want to see everybody getting connected, but I don't want everybody to download that big file that I have set up in my test. So what you can do with CyPerf is you have a primary objective, but you also have a secondary objective. And if you enable a secondary objective and set up throughput connections per second, so this is where you limit the traffic. You still see your latencies, as I said, right? The KPIs still remain the same. You're seeing your latencies, your steady state application attacks and everything else, but you're not overwhelming anybody else.
So I guess the secondary objective would be more like a constraint.
Yes, more like a constraint. You're right. It's more like a constraint. Absolutely. Yes.
Yeah.
And it's especially important for network equipment manufacturers and service providers for cost control.
Yeah.
Because cloud, even though they say it's cheap, can very quickly add up per second, can very quickly add up if you're running high volume tests for a longer duration.
Well, I guess from a load test perspective, it is an objective, right? Because you want to make sure, you want to guarantee that you're doing X, right?
Right. Yep.
Whatever that throughput or.
Yep.
But from a security zero trust measurements perspective, I guess that is a constraint then, is that?
It
Is
is
that accurate?
That's absolutely accurate. But even when, I think Zach touched upon it a little bit, a lot of bad things can happen when you're actually at a lot of higher load. Because believe it or not, security devices can do what is called like fast passing, where they are not detecting at the level that they were before, right? So sometimes they need to do that kind of test where auto scaling is happening because traffic has triggered a scale policy, but also sending attacks to see whether the new pods that are generated real time are not vulnerable during that time when they're coming up, or lambdas or whatever they're coming up during that time. And also you're not dropping a huge amount of traffic while maintaining that kind of scale behavior.
What's the business model? Who do you sell this to other than Kevin Tolley? I mean, it's perfect for what he's trying to do. And who is your customer?
So we have 3 segments of customers. Our first customers would be the network equipment manufacturers. They're all rushing towards the cloud. They're all deploying or coming up with their software-defined perimeter solutions, zero trust solutions, all these things, right? And they
set that up with real Facebook accounts and real Oracle database accounts as the network equipment manufacturer, or do they simulate both sides?
They simulate both sides. So that's another very good question. So we can try to send traffic against an Office 365, but we'll be really limiting ourselves. Otherwise, Microsoft will come to us and I will be in jail, right? If I send too much traffic on Office 365 accounts. For a network device that is sitting in, let's say, closest to Azure, wherever the Office 365 is hosted, all they care about is traffic that looks exactly like Office 365 and goes to a destination. You cannot do an exact routing rules, but NEMs can change and can change their DNS policies to mimic that. And they are still able to create Office 365 or Facebook-like traffic that they can see whether their DPI engines, their security engines are still able to provide the right kind of policies that is needed. For example, there is a good chance Facebook chat is allowed in your company, but sending any attachments to a chat is not allowed, right? So a security device needs to block specific actions within an application, and they have to do this at a scale. When you're doing it singularly, it's very easy to validate. But when there are multitude of Facebook transactions, Office 365 transactions, application transactions coming in, that's a whole new different challenge. And that's what they want to measure.
So that equipment manufacturers.
The second one is service providers. So service providers are going through that same kind of progression towards cloud, towards adapting these technologies, right? I have heard of, and they're very public about it, where AWS or Azure are being used for deployment of 5G model, right? And if you know, 5G is fully containerized. So they have now the need to test same kind of scale, auto scaling, performance, and all their security stuff that were working in their on-prem data centers being able to work exactly like that in that place. So they are our second biggest customers. And of course, all of our customers is ultimately the enterprises who are also doing CI/CD. And CyPerf being not a big hardware that you have to do, but a simple software that can be popped up after you have a controller, makes it perfect for the CI/CD pipelines, where if they're onboarding new technologies for Zero Trust, let's say for Zero Trust, they have to test. If they're purchasing new VPN, they have to test it for scale. So they can also onboard it. But it is in that order because NEMs have the absolute responsibility for the QA to be spotless so that their customers don't find it. And second is the service providers because they are going through that cloud transformation. And the third would be enterprises.
Thank you.
Yeah, and architecture validation, right? So for example, we had a customer that is a mobile network operator, right? And they've done a mistake in their failover, and all the traffic was routed to a region, and all that firewall infrastructure crashed, right? So their network was out of business for a few hours, right? So many customers like to create these, let's say, digital twin type of replica of the architecture that they want to deploy. And now, because you have the ability to insert this traffic at scale, right? Think about when you say scale, it can be as big as the size of a continent, right? So that volume of traffic now, you can inject it in a cost-efficient way in your architecture, and you can see how the architecture responds, right? That's an example. We have customers, so for example, on Microsoft Azure, right? Microsoft Azure is a public cloud, and they have this Azure distributed denial of service as a service that they provide to their customers, right? And we have customers that wants to understand what is happening with the quality of experience of their application when someone is attacking them. So we have a tool that we built with Microsoft just for the distributed denial of service because it was supposed to be safe, right? And we took specific measures. But how do you see the impact in the quality of experience is using a tool like CyPerf. So CyPerf now can replace the server side and is replacing the users that you have in the public domain. And now you have the legitimate traffic, the application traffic, voice, video, whatever you have. And at the same time, you see distributed denial of service. And maybe for a few seconds, you'll see an impact in the quality of experience, right? So this is just giving you a lot of data that allows you to build better architectures and take business decisions based on actual facts rather than a guess, right? And I think, especially in the public cloud, because probably a question that no one asked is, why are the service providers and enterprises are still testing, right? It's like if the network equipment manufacturers start testing, why do you need to validate as an enterprise or as a service provider, right? The reality is that most companies learn in the hard way, right? People lost jobs, they've deployed, that there were problems with the configuration that they had. They put it in the network. The business impact was big. They lost their job, and the next person there, took the measure to actually be better prepared and be proactive about this type of issues.
So when we say that an enterprise may not want or need to do the validation, isn't that potentially because the manufacturers of said software have published numbers that turned out to be false in past history, right? And so when we deploy it in the cloud, we can't trust it, right? So we still need to test it to some degree.
Yeah, it's not like we cannot trust them, right? I think that's not the problem. They are doing their best to provide, let's say, a level of standard measurements that everyone can understand and correlate. The reality is specific with content inspection devices, right? The ITS, DLP, and so on, is that traffic mix and the content that you have in the network makes a big difference. So as an enterprise or service provider, your traffic mix will be probably very different. Like if I go to Costco versus Walmart versus a different company, I'm pretty sure the type of traffic that you see in that network will be different, right? Our company, for example, we went through a similar problem. It's like when Keysight acquired Dixia, they were not aware of test tools and how they can benefit. And we had a firewall vendor that was in-house, and we had some issues with the firewall that they were not able to replicate. And when we started presenting our products, they said, like, okay, let's prove it internally, right? Show us that you have value. So we did a POC. Actually, Amritam was there. He ran the testing, and we were able to reproduce the issues, right? It was very easy for them to take it, send it to the vendor. The vendor got a patch, they fixed it, and they were happy, right? At the same time, they did a major investment in the next generation firewalls that we had, right? And they were prefer a particular vendor. We had good support, but they said, okay, let's use this opportunity again to do a proof of concept. How do this vendor with this vendor compares, right? And what they've actually learned is that none of the two vendors were the best fit in all the parts of the network, but one was a better fit in a data center and another one a better fit in the branch office, right? So that type of data, right, is like when you put it on the table and you go to your CISO and say, this is why I need it here and this is why I need it in this location, you eliminate all that preferential vendor aspect, right? So those are like problems or examples that maybe put it in a better light on how customers can benefit from our technology.
So here's a question for you. Since you have a great capability, as you've said, right, to generate workloads, how about this? Could you capture an ongoing workload from a customer? Imagine, the quintessential high seasonal volume.
Yeah.
Play that back and be able to ramp it up to 10x of that, and then add in some malicious stuff.
Yeah, that's a great question. So we have multitude of products, and one of the product, which is basically the predecessor of CyPerf, does exactly that. We have a tool that you deploy in your network, and it takes all the traffic, let's say 24 hours of traffic signatures, compresses it into whatever file that we have. We upload it in our file, and just exactly like you said, it becomes another test now. So you crank it up to throughput, hundreds of gigs of throughput. You start enabling decryption so that you can see the traffic in clear text. You add attacks through it. You can do all those stuff. CyPerf is a relatively newer tool, so we were going to integrate it, but we have not yet added that in CyPerf. But it is there.
Presumably, you're planning to do that.
Yes, absolutely. Because the signatures, the applications don't change if you move from cloud to on-prem. Applications still remain same application. So yes, we have the applications already. We just have to have a way to integrate that format into CyPerf and replay it.
And I could see we were talking at lunch a little bit about the Facebook issue when I wonder what'll happen if we mess with our DNS and then finding out that, we can't even get back into the server pages to fix the DNS. Yes. This would better be another great tool for companies to evaluate stuff that, what moron would ever do that? Well, somebody did it and essentially shut people out of their entire systems.
That point being made is that you do not always have to go to the real application to test the application, right?
Right.
The cloud gives you the flexibility to go closest and create that application traffic that simulates it. Your middle devices don't care, right? Which IP address the DNS gets routed to, as long as you have control of it. Right. Thank you, sir. Right. So in case you missed, we are still going through that evolution phase, guys. So we are now in the cloud. And I know I already talked a little bit about it, but the point I wanted to make sure is that when we deployed cloud and we had servers and things like that, it allowed us to create devices, and we have incorporated various types of devices. You can have them in reverse proxy, transparent proxy, explicit proxy mode. You can add your SASE, secure access as service edge. You can have your secure web gateways by giving the FQDNs, and all this can be integrated because this tool can work distributed and it doesn't care where the security devices are, just like users should not care about it, and you should be able to test it. Now, just like the progression, I'm not going to talk about this cloud in isolation, but let's add it to our existing topology. So we know we went through the on-prem phase, we have added VPNs, and 5 years back, you have started adopting cloud. The same cloud endpoints gets adapted. The difference here in this case is now our workload starts becoming more complex. And now you can see we have the VPN apps, we have now Office 365, Salesforce, AWS, and you can also have self-hosted applications like Jira that you can self-host or use the SaaS-based application. The important point is all three are coexisting together, and our enterprise is growing nice and slowly from 5,000 users when we had VPN, now we have 6,000 users. So let's go to the statistics because this test is also pre-run. And we can see the KPIs. Obviously, there is a little more throughput now. We can see the VPN tunnels getting established, the 2,000 tunnels concurrently. We can see all the applications and things like that. But the interesting part in this is you can see there is a nice blip here. So there was 3 agents at the client because one was on-prem, one was running VPN, one was running cloud. At the server also, there were supposed to be 3, but here we see 4. Because what we did is while the test was running, we did something called auto scaling, where we force the servers to be expanding. And there are various ways to do auto scaling. Forcing it by sending a lot of throughput connections, so your scaling policy gets triggered. Forcing a lot of compute intensive traffic so that TLS things, so that your CPUs get triggered. So that creates another. The easiest way I found out is to just increase the scale forcefully. So that's what I did, and you can see that in AWS log. And if I go to my statistics now, you would see the impact of the load balancing, the transactions, and everything else. So I'm going to just focus on the 2 instances that did the auto scale. You can see that, right? It's beautiful. I love it. The first traffic was coming through was 89, this 172.16.6.89. This was the first cloud instance. And while the test was running, I brought in another instance. This is a big leap for a test tool to do. Because if you are in the hardware segments, which I was also from very long time, of course, with little less hair products, what used to happen is that all the ports needed to be on and needed to be green before you can even run or start a test. Now here we are in this topology where the instances didn't even exist before the test run. And it's due to the test run the auto scaling happened. And this allows us to test some of those corner cases, like will the auto scaling work properly? When the instances come up, will this create some security issues? Will my authentications will fail? And things like that. So that's what cloud allowed us. So to go to zero trust, let's understand this flow of transactions, right? So again, we are going to simulate the client that's going to create this transaction that gets intercepted by something in between. This is generally called a policy enforcement point, or PEP. In our case, I'm going to use Cloudflare 1. And generally, policy enforcement points redirect it to identity providers or IDPs. Sometimes PEPs already have integrated IDPs in them. Sometimes they redirect it to a third party. This makes it much more cleaner because you do not have a single point of failure. Now, once that happens, you give your authentication, your credentials, and everything else, and that redirects you with a token back to the PEP, and then you have the transactions to the application. It's a pretty complicated transaction, which I have simplified it into 4 or 5 steps, but each of them would have multiple redirects. You will have tokens that you have to carry over to the PEP. PEPs will give you authentication cookies that you need to use for the subsequent transactions, and you have to ensure that you can share those cookies between next transactions so that you don't have to authenticate again and again. You are trying to make people's life easier while giving them security to do zero trust. So we are going to do this exact same thing with our zero trust test. So you can see this zero trust test. I have some clients. This is again a vanilla client in cloud. But what you see in the devices is the same transactions. You have your web servers, which is the app that is getting hosted. But before going to the app, you will be redirected to the PEP, ideally in real life, and then an identity provider where you provide your authentications. So you can see all these transactions can be edited and added in applications. Okay, and this is true for all our applications that you see, Office 365 and everything. This is parameterizable. Not everyone has authentication, but if it has authentication, you can parameterize it. So you can see all this authentications. I had created a valid app and an invalid app. This is the name of the guy that created all this. So a shout out to him. And you can also see now some interesting things, like I can do only the client side encrypted. I can create different encryption schemes. I can have client-side encrypted, server-side unencrypted. I can use 1.2, 1.3. So all the different demands of zero trust testing can be done with this approach that we have with CyPerf 2.0. This is our big launch. So shall we run this test standalone and spoil this entire flow that I made? Not on my watch. So let's integrate it into these applications with everything coexisting together, right? So you can see We are already aware of most of these guys, right? We know our on-prem guys. We know our VPNs. We also know our cloud, which is going to an FQDN in AWS with a load balancer and everything. And we have added some zero trust clients. This is probably exactly how it will happen in real life, where you are not going to onboard everything together. Most of us don't even know how many assets we have. I'm still using a very old laptop that I have not returned to Keysight. Sorry, Ram. But I'm going to after this. The point is, we would not know all these things together. So we will onboard one after other, right? And that's what we are doing here. You can see all this coexisting in a happy kumbaya with applications, attacks, and objectives. And let's go to statistics to see. So our KPIs will show the same things. Again, you are already aware of it. Our VPNs are there. Everything else is there. So here I'm going to focus on statistics that is specific to zero trust. Now, sir, you asked me for a problem. So we see a small problem here. There is one transaction that has failed for a very, very small number of traffic. And that's intentional because we are going to cloud services. We want to be respectful. We don't want Cloudflare or Okta to come after us. They already have their own problems as we speak. But you can see here the whole transaction that is going through, the dynamics of the transaction for these apps and the details that we can go through at scale. So you can see how many Cloudflare requests were done. And you generally would see the valid requests are smaller than invalid because you fail quickly. For passing, you have to go through that entire hoop. So that's why you see that differences. You can also see individual PEPs and identity providers listed, like you can see Cloudflare and Okta listed individually. It's very important to do that. And you can also see, our applications are successful, and you can see that we're reusing some of these cookies. Like if you see the number of transactions, the number of authentications that we have started is actually 1/5 of the number of transactions successful. So this is what shows that once the application authentication is successful, the subsequent transactions do not need to be authenticated again. So this is where the cookies are useful. And that's where, Bruno, I wanted to come back to you and show you that this is the scale that we went for. And then we have to add two-factor authentications as our customers would definitely demand it.
That ratio of 1 to 5 that you
Yeah.
just mentioned, do you have an app that we could set on our network to figure out what those should be? Because if you had 100% new users, it would be 100%. If a user gets on and he uses the same auth over and over with his cookies, it'd be different. I don't know the ratio I should be putting in.
Right. So neither do I, and I have to be very honest. As a test tool, what we try to do is open this up. So we have opened that up to the customers to decide. So you can specify that. Okay, every 10 transactions needs to be authenticated. So that's how.
I was just wondering if you had a tap or something that you could figure it out for us.
No, but that's a good product idea for us. So, but
Free.
yeah.
You can use it.
This progression allows us to onboard different types of security devices, products, feature, components in our systems, right? Like you can see, you can add microsegmentation to zero trust, right? Because everything is in a single tool. So if you want to test microsegmentation, like, okay, there are secure networks, V6 networks, really unsafe, really, really unsafe, or, oh my God, it's XP. Whatever networks you have, whatever devices you have, you can test it. And I say it in jest, but for IT teams, it's a real problem. Sometimes they cannot replace, the healthcare industry and some of them. The companies refuse to patch those systems. They are very antiquated systems. But what you have to do, you have to protect your weakest links. So with microsegmentation, that allows you. And what you can do here is, like you see, our on-prems can be brought under zero trust fold, and you can test it. And you can add things like cloud. The other progression would be, which I predict, and I'm very sure this is going to happen, is VPN and SDP clients coexisting together for a very long time. SDPs are very expensive to get seats, right? People already have invested in VPN. They're not going to remove all VPNs and convert everything in SDP in a single day. But you need to test both as you start onboarding SDP clients along with VPN, and you need to see the statistics to see what kind of issues you have, if there are security problems and things like that. And another last point that I did not highlight was that all this can be done not just for applications, but for attacks. So every traffic that we saw today, obviously we have applications, but if you shift this tab, it's attacks. And in attacks, we again try to go for a different depth. For example, we have our pre-canned attacks. So if you are not really a master hacker, you can select from some of these application attacks like brute force, denial of services would be great for zero trust testing, right? Similarly, you can also create some very specific attack strategies where you can add your attacks into applications, right? So you can create your applications and add strikes to it. Let me do that. So CyPerf as a tool, I think there was a lot of questions on this, is the only tool right now that allows you to have applications like Office 365. This is where the realism matters. And you can just say, okay, let me have a ransomware here. And you can introduce ransomware right in the midst of completely legitimate Office 365 transaction. This is as real as attack profiles can go because it doesn't come in isolation of single malware. It generally gets hidden within this complex set of applications, emails, attachments of an emails and things like that. So that's, we are allowing you to do that as well.
So does there have to be like a coordination with the attack, with the security team to have some sort of allow period or ignore period?
Right.
We're going to run this. Please don't just shut us down immediately, right?
Yeah.
Otherwise, we've proved that another solution works, but not actually full impact.
Right. If you're a person like me, you will do that first and then ask for forgiveness. But yes, ideally, you should have that coordination. But the important point you raised is that because we are a two-arm attack tool, we are generating the attack. We are also consuming it by ourselves. It's much more controlled and it's much more within that gamut. So for example, I'm sending attacks all the time from different clouds, different infrastructure. Because it's all my infrastructure, AWS never has called me for abuse report or any other cloud. So that's the important point that I want to also raise.
There also a dashboard or a view if we wanted to scale into multiple clouds.
Right. So this controller is a single controller, right? Mm-hmm. The good thing is of designing a tool ground up is that, let me open an actual test to show you, is that we can leverage some of the existing technologies, so or newer technologies. So we use leveraged Grafana. So for example, you want to have specific cloud, specific dashboard that has to be very specific to your needs. You can absolutely do that, edit that dashboard. Most of these are REST API based. So, and officially we generally I mean, we have provided enough statistics to the customers to do that, but if they want to customize dashboard to have specific views, like I just want to see zero trust authentication and my application, you can customize that with Grafana, just like I showed you here.
Injecting the attacks or whatever, is that done in payload with legitimate traffic, or is it just a separate connection, or does it depend on what the attack vector is?
Absolutely. So it depends on how the attack vector is. But the cool thing in general, up till now, all the products that we had done, attacks were always going in silo, although we had applications separately. But here, within the transaction flow, like you sign in an Office 365, then you send a legitimate attachment. The third transaction can be where you send a link which somebody, let's say, clicks, and then you add an email. The next email has a malware file within it.
So like there's like an SSH attack from back in the day is another TCP connection on 22 versus O365 is a continuous connection with transactional base. So it just sort of shoves it in the middle there.
Yes, so you can. So it's basically giving you flexibility to do either standalone or shove it in the middle of a transaction, existing transaction, like I did in this particular case, where you can see that.
Oh, okay, yeah, I didn't catch that part. Like that's a task list.
Yeah, so you can see this. If I expand it, it will tell you what exactly this attack is, what it does, and it's introduced within the transaction.
That's nice.
So I got the question from Charles here. So he's asking, is there something that's missing, or what's the next step, right? We've gone from on-prem to zero trust. What do you think is missing in CyPerf from a next step?
Absolutely. It's not a complete product. We are trying to go after the curveball here, right? We are continuously trying to see what are the new things that are there. So some of the web versions like HTTP 3, which I know is coming at a rapid pace, we don't have it yet. So that's one key feature that we think is missing. CyPerf can be deployed in a variety of systems, but it cannot be deployed natively on Windows. So although you can have a virtual machine within Windows and deploy it, so those are the two things I think is important and it's missing.